Hey guys, welcome to another video in my AP Biology or Biology Olympiad Prep playlist. In the last video we discussed different types of chemical bonds, namely covalent bonds, ionic bonds, hydrogen bonds, and van der Waals interactions. Today we're going to be talking about the special properties that water has because of its ability to form hydrogen bonds. If you didn't watch my previous video, I can link that down below because it goes over the basics of hydrogen bonding, which you need to know in order to understand this video. Let's get started. The first property we're going to be looking at is cohesion and adhesion. Like we talked about before, water molecules have partial charges. The oxygen has a partial negative charge, and the hydrogens have partial positive charges. So when a water molecule comes in contact with another water molecule, wait a minute, let me draw one right here. Partial positive, partial negative. The opposite partial charges attract with each other. This forms a hydrogen bond. So basically what's happening here is these two molecules are sticking together because the opposite charges attract, and that's exactly what cohesion is. Cohesion is when water molecules stick to each other. Now, water molecules can also form hydrogen bonds with the molecules of other substances, and that's what adhesion is. Adhesion is when water molecules stick to the molecules of other substances. You can see this when you fill up a test tube with water. There's a sort of curve in the water level. This is because the water molecules form hydrogen bonds with the glass. So the water molecule over here forms a hydrogen bond with the glass wall of the test tube, causing the water level to raise at the edges, forming this curve which is called a meniscus. Now, because water molecules form hydrogen bonds with each other, it has more structure, meaning it's harder to break water's surface compared to other liquids. So let's see, we have the surface of water here, which I'm drawing right now, and these are the water molecules. And the yellow lines in between are hydrogen bonds. Now, in order for a substance, which is indicated by the red block here, to enter water, it has to break through the hydrogen bonds as well, which makes it harder for this substance to break the surface of water. This is called having a high surface tension. You can notice this when you slightly overfill a glass, but the water doesn't overflow. Or right before the swimmer over here rises above the water in the swimming pool. It seems as though there's an invisible film over the water level. Surface tension also allows this spider to walk on water. If not for the hydrogen bonds, the spider would fall through. The second property we're going to be looking at is water's high specific heat. Specific heat is the amount of heat it takes to raise the temperature of 1 gram of substance by 1 degree Celsius. For water, its specific heat is 1 calorie, which is really high compared to other substances. To give you some perspective, ethyl alcohol has a specific heat of 0.6 calories. The reason for water's specific heat goes back to hydrogen bonding. Let me draw a beaker here filled with water. Again, these are the water molecules and the yellow lines are the hydrogen bonds. When heat is applied to water molecules, the heat goes into breaking the hydrogen bonds before it goes into raising the temperature of water. Therefore, more heat is required to raise the temperature of water. This is a very helpful property. 70% of our body is water. If water did not have a high specific heat, our body temperature would fluctuate very easily, which is not good because enzymes and other proteins in our body need a very specific temperature to function properly. The high specific heat of water also prevents fluctuations in the temperatures of large bodies of water, which creates a hospitable environment for marine life. Water also has a high heat of vaporization. Heat of vaporization, as the term suggests, is the amount of heat it takes for a substance to evaporate, that is, convert from a liquid to a gas. The reason for this is that heat goes into breaking hydrogen bonds to separate water molecules before they can evaporate. As water evaporates, it cools the surface that it evaporates off of. This is called evaporative cooling. An example of this would be sweating. So let's say this is your skin and those are sweat droplets. What these droplets do is they absorb heat from your body in order to evaporate. So because your body is giving up heat in order for these droplets to evaporate, its temperature decreases and you cool down. This property prevents organisms from overheating. The third property we're going to be looking at is the fact that ice is less dense than water. When most substances freeze, the solid is more dense than the liquid. Water is an exception to this pattern, and again, this goes back to hydrogen bonding. When water freezes, the hydrogen bonds between the molecules also freeze. So those are the frozen hydrogen bonds, and this results in the molecules being arranged in a crystal lattice, but it also leaves a lot of space for air in between the molecules, which results in ice being less dense than water. In the winter, when lakes and other bodies of water freeze, the ice floats to the top because it's less dense, and it acts as a barrier between the cold air and the body of water. This results in the water being relatively warm, and it can sustain marine life, and it creates a favorable environment. But let's say that ice was more dense than water. If this happened in the winter, when the top layer of water froze into ice, the ice would sink to the bottom. And then you would have the top layer of water freeze again. And then it would sink to the bottom again. And this would repeat again and again until the whole body of water was frozen solid, which would not be sustainable for marine life. So that's why this is a very helpful and important property. The last property we're going to be talking about is water's ability to dissolve other substances. Water is a versatile solvent. A solvent is a substance that dissolves other substances. A solute is the substance being dissolved, and a solution is the mixture the solvent and solute make. So let's say you have a beaker filled with water, and you have salt dissolved in it. What is the solute and what is the solvent? I encourage you to pause the video and figure this out yourself. Alright, in this case, salt is the solute because it's being dissolved, and water is the solvent because it's doing the dissolving. Water dissolves salt. Now let's get back to water, what we were talking about. The reason water is such a versatile solvent is because of its polarity. Because of its partial charges, water can easily dissolve other polar molecules. For example, sodium chloride or table salt is dissolved in water like this. I drew a diagram of the ionic compound. The chloride ion's negative charge attracts the partial positive charges of the hydrogens on the water molecule. So they arrange themselves around the ion like this. So what they end up doing is they pull this ion away from the compound, and they form this ring around it of water molecules, and that's called a hydration shell. The same thing happens with the sodium ion, except this time it's the negative charge on the oxygen that's attracted to it. So slowly, ion by ion, this entire compound disintegrates and dissolves. Therefore, because of its polarity, water can dissolve ionic compounds and other polar molecules. However, nonpolar molecules cannot be broken apart by water's partial charges. So nonpolar molecules are not soluble in water because they don't have partial charges that water can use to pull apart the molecules. These substances are known as hydrophobic because they reject water. On the other hand, hydrophilic substances are substances that have an affinity for water. Hydrophilic substances don't necessarily have to dissolve in water, like a cotton towel, for example. A cotton towel is a hydrophilic substance. It soaks up water, but it doesn't dissolve in water. Water's ability to hydrogen bond gives it many unique properties, and its presence gives the Earth the ability to support life, which is why these bonds play a huge role in biological processes. So that's all for today. If you have any questions, feel free to comment down below. Please leave a like if this video helped you, and hit that subscribe button. I have linked the notes and a checklist of everything you need to know from this chapter in the description box down below. And good luck studying. Bye!